So number 5 on page 317. I want to do 6. And it's given us, I always like to lay this thing out this way, even though we're not going to use all these parts. We're given B is, this one here is 60. And 82. And then we're given this one. Now notice that we have 2 sides and a not included angle. That would be what we're working with today. If we had side C, then we'd have side angle side, right? And that would be what we're going to talk about in the next section. So now what we can do is we have enough information to use the law of sines to figure out what angle A, capital A is, this one. Because we could go the alternative law of sines, we could use sine A over A equals sine B over B. And then sine A, we do not know what that is, but we do know what A is, 82. Then we could go sine of 100 over B is 60. So the sine A equals 82 sine 100 over 60. So what we'll do is we'll calculate that out. 82 times sine 100. I'm gonna force this to be degrees because I don't know for sure what I got, and I'll change the mode later. And then divide by. Okay, so can I have the sine of A equal 1.3459? Is that possible? No, sine's got to be between 1 and minus 1. So there, and notice what's it asking? Determine the number of triangles ABC possible with the given parts. So the number of triangles possible is 0. Because this is not possible, right? And so here we're given 35, 30, and 40 degrees. So this one, I'm going to solve for sine B, right? Over B equals sine A over A. Does everyone understand why you see I'm setting it up so that I don't have to manipulate the problem any more than I have to. So then sine B, we'll put over 30, sine of 40 degrees over 35. This mode change. I'm going to go 30. Sine of 40. Because I got that mode set in degrees, I won't have to do that degree. All right, so notice.
Divided by 35.
Okay. This is supposed to be 35. So if you look on the previous page, number 3 says 0 is less than sine B, which is less than 1, which is just so happens to be sine B. So then either 1 or 2 triangles satisfy the given conditions. They want us to know, determine the number of triangles ABC possible with the given parts. So there's 1 or 2. Now, if we wanted to know which one it is, then we would have to, I think this is, I'm going to do sine inverse, and that will get, this is the angle that I have. It's 33 degrees is what B is, right? B is going to be, because I'm doing sine inverse of this thing, right? 30 sine 45, 35. And that gives me the 33 Now, the angle that this, the complementary angle to this one, that would be a possibility. This would be B1, is 180 degrees minus 33.43 degrees, right? That's the other angle that would have that same sign. It's because the previous one, because see, there's no such thing. If I tried to do sine inverse of that, it'd give me an error because sine of an angle cannot be greater than 1.
So
That's why there's no. Then it's okay. You can see sine of any angle falls any place between -1 and +1. Remember the sinusoidal curve? The amplitude is always 1, or else it's whatever is out in front of this times 1. Yeah, this would have been between 1 and -1, but in when you're doing these law of sines, it'll be between 0 and 1, because you'll never get an angle down greater, see, it has to be something between 0 and 180 degrees to be an angle of a triangle. So that's only going to be first and second quadrant angles, because you can't get in the third and fourth quadrants, because then you're over 180 degrees for the angle, and that's not possible. You can't have an angle of a triangle that's greater than 180 degrees. So you can't have the sine inverse of a negative something between 0 and -1, because then you're going to get an angle. Then you theoretically be talking about an angle greater than 180, less than 360. Well, it's not possible. You can't be in that realm, correct? Because there's only 180 degrees in the triangle. So any angle in the triangle has to be less than 180 degrees. Does that make sense? So you're only going to go between 0 and 1. Did that answer your question?
Yeah, but I'm just asking it like if that was the true to that, then if you would inverse that one and continue on with it.
Yeah, if this would have been something less than 1, then you'd continue on. But when it is greater than 1, then there's no triangle. Okay. Now, so if there is another angle, then it would have to be, what is it? What is this when you subtract it? 146. I'm just going to round it off at 6. Something like that, right? 0.6 is good enough. It'll work for our purposes. Now notice that if we take 146 and 40, because this angle's got to be there, 40 degrees. And 146 and 33.43, or I guess are going to both give us this same value here. So the third angle, what did I have? 40, 180 degrees in a triangle minus the sum of 40 degrees and 146, if we want to do what Chris said is 5/7. That's possible, isn't it? That's not possible, is it? 186.57. You can't see, there isn't enough room to put another angle in there. So this is going to be one triangle. Now if this angle were less, was enough less so that when the sum of these two was less than 180, then you'd have two triangles. If you look back at 313, if this is the situation, the third one down, notice that the sine of b was between 0 and 1. That's what this was, right? See when we did it. This value here came out to be 0, between 0 and 1. So it was either going to be the third or the fourth one down. Then to figure out which one it was, you'd have to figure out what angle this is. And then the angle that will have the same value as this one is its supplement, which is 180 minus that. That one and this one have the same side. Then this 146 plus this angle, if you got a triangle that actually has 146, this angle plus 146 has to be less than 180. and it isn't. So what you do is you have this triangle with too long a leg. And you know, if you drew this thing out, what if I can draw it out? I got I can get this straight. Which sides I got? This one would be 40-degree angle. This one would be 33 point, whatever that one was, 43 degrees. And this is A. So this is the 35. And this one was B, right? And this is 30. And that's C. So the C if I add these two together and take it away from 180, that would give me the angle up here. But the other angle that this thing can be would be swinging this thing around back down here. And you see it wouldn't close. It would close on the back side. That side is too long and it closes back over here on the back side rather than on the front side. If I had two triangles, I'd have to have something that would look more like this, so that when I swung this, and I'm even too long here, it would have to be it's got to be something so when this swings, it hits right in here. I don't know what it is. They're showing you the picture right there on the fourth element there. You'll see that the one that we have here is the third one down. If that A side comes around, it will swing up on the back side of that triangle. If you have two of them, then that A side is short enough so that it swings around and hits on the front side. And the way you tell it is when you sum these two, you got to have, this has got to be an angle also that fits 180 degrees. I can see it. I haven't explained it to you, but let's just say this one, the answer is it has one triangle. Now, 10 will do the same thing with 10. A, B, and here we got B is 54. C is 28. B is 23. Now, the angle that we can calculate is going to be this angle C here. So I'm going to go sine of C over C equals, this is the law of sines that I'm going to use. And so if I substitute the values that I know in, I get 28 sine 54, 23. Equals 28 sine 54 over 23. So the first thing I'm going to do is see if I got the possibility of it being even one triangle. 28 sine of 54. Wonder if I might have to put a times in there to be safe. Now, I'll write this out because what I'm getting is sine C approximately equal to 4.985. I'm going to show you the angle that we have here. C, the angle C, is going to be sine inverse of this 4.985. But I'm going to do it accurately because I'm going to use this value right here. So I'm going to go second sine inverse of that so there's the angle I have. This angle C is 80 degrees. Now the question is do I have another triangle? And the angle that will give me this value here is 20 degrees, right? No, it's 100 degrees. The C2 that I can get is 180 degrees minus 80, which is 100. Just to show you, I should be able to get this number right here by doing sine of 80. See, if I do sine 80, I get that number, right? And if I do sine 100, I get that number. There are two values that get that 0.98. So here are the two. It's 100, so there's C1. I can have a triangle C1 or I can have a triangle C2. Now, if I have this one, then this angle right up here is 180 degrees. That A1 is 180 degrees minus the sum of these two, 54 and 80. So this angle is going to be 46 degrees, right? Now, what I've shown is that I can have C2 that'll meet the criteria of 54 over 23 times this thing, or divided by this thing. No, times that thing. Now, the question is, I have to use this B again is the sum of these two, less than 180, so that I can have A2 up here. And it is, right? If I add these two together, I get 154, and this can be 26. So what's two possible triangles? One is a triangle that has 46 degrees at A, 54 degrees at B, and C at 80, or the other one is A is 26 degrees, B is 54 degrees, and C is 100.
So two triangles.
There's two triangles. I should go back to this one and show you why this one doesn't work. You see, if we go back and we get this B, B1 can be 33.43, right? So B1 can be 33 point, I just want to do 4. I don't want to do all that decimal stuff. Then this C1, if this were the case, this would be 173.4. So this angle would have to be what? 102.6. Is that right? This should 107. Yeah. 106. Can't subtract. See, if I add these up, this is 10, then this is 10, 1 to carry, this is 8, and I have 180 degrees. That's a triangle, right? 180 degree triangle. Now, I calculated this B1. Well, the other B2 that could have this same value here would be 180 degrees minus this, right? And that one came out, what was that? Okay. Yeah, that's 146.6 degrees. And see, it has to have, this angle has got to come across as 40. And now this C2 has got to be 180 minus these two, and that's not possible. You see that? See, this would have to be 180 degrees minus the sum of 40 degrees plus 146.6. And this is 6 degrees, 6.6 degrees bigger than 180. It's not possible. That's why this one has one triangle. And when we did this one, we had two. See, in this one, the calculated triangle was C1 because you were given B and C. So then there's always a supplementary angle that will give that same value that gets this. That's why it's a little complicated doing the problems, but you're going to have two. You can only have two. So what you have the possibility of is none, and that's when you do this initial calculation right here, and it comes out to be greater than 1. There's none.
Say, was a possibility of there being 3 this property so close.
There's no possibility of having 3, but I guess you would be right. You'd have to calculate it in this manner, but
yeah.
There's no way you can have 3 triangles that fits the criteria. 2 would be the maximum. But when you get 1, the time that when this sine of this equals 1, then there's only 1, because then it's a right triangle. But when this value right here is between 0 and 1. Then you have this possibility of 1 or 2. Does that make sense? It's only when this thing right here is between 0 and 1 that you have to get all this extra stuff. If this, when you do this calculation, if this comes out to be 1, it's only one triangle, and it's a right triangle. If this is over 1, it's none. But when it's between 0 and 1, then you got to go through all this mess. And you see, we can calculate with this one. We can get, but there's going to be two values of this A, right? One when you have this triangle, and one when you have this triangle. So you'll have A1, A2, and small side A1, and then small side A2. But they'll turn out to be the same length. Okay. What we'll do is we'll go ahead and we'll look at some more of the problems. Let's look at 14. It says find the unknown angles in triangle ABC for each triangle that exists. And what I'm going to do is, because when I give you the problems, I'm not going to ask for something that has unknown angles. I'm going to say, here are the values given to you, and calculate the rest of them. So B says, 14 says 48.2 degrees. This is A is 890, and B is 697. Now, when you're doing it, what you have to do is you have to decide what's going to apply. And the way you decide that the law of sines is going to apply is you have to have it so that you can do a side and an angle. There's got to be an angle given you and its corresponding side. Then the law of sines is going to work. It don't make any difference whether it's two angles and a side, or if it's an angle or two sides and an angle. If you have a side and its opposite angle, then you use the law of sines. In the last two cases, you see it would be an included angle. So if you were given these two sides, what angle would you be given? C. See, if it were ABC, if it was AC, what angle would you be given to use the other one? Then you'd be given this angle. See, if it was that way, then you couldn't use law of sines. It has to be the law of cosines. Does that make sense?
Sort of, yeah, the law of cosines is what we're doing next.
It's always going to, you're always going to be given one angle and a couple sides, or else you'll be given three sides. Or, or else you're going to be given two angles on the side. Well, if you're given two angles on the side, then you're given three angles technically. But when you're only given one angle, then what you have to watch for is if it's a law of sines, then you have the side opposite that angle. Then it's a law of sines. If this angle, you're not given that side opposite, but you're given these two sides, then it's a law of cosines. So you got to kind of decide when you look at what's given to you, what am I going to use? And this is the law of sines. Now, what we're going to be able to do is, because we're given this side, we're going to be able to calculate that angle, right, using law of sines. So we will do the sine of A. And, if you want to, rather than go through the step where you go sine of A over A equals sine of B over B, you can say, I'm going to move this A up there and I'm going to insert it like that, right? It's sine of A over A, but I'm going to move the A up there because this is what I don't know. So that sine of A is 890. That's what the side A is. Sine of 48.2 over 697. Now at this point, you'll be able to determine if you have the possibility of a solution and how, how many there can be. Okay, so what is this telling us? There's going to be at least one, right? But now we have to decide whether there's another one. Now, when you're given this, then what you want to do is because I'm going to have you do fill in all the blanks. Then you go second sine inverse of that value. And then, so we have 72, and I'm just going to round off to one decimal place because that's what this one is. So this is BA. This is my angle. This is the one that I've calculated. 72.2 degrees. So I have A1. Now, I can figure out C1 by taking 180 and subtracting the sum here, right? This one's going to be 180 minus 72.2 plus 48.2. So what is that? Ten, 130. Was that 49.6? Is that 49.6? Huh? 59. One. I can't hear. What is it? 59.6? Okay. Now, remember that this was the one we calculated. So what the complementary angle, this is the one we're going to figure out by doing 180 minus 72. And that one's going to be, what, 107.8? Is that right? Now, this has got to come across as 48.2, right? Now, this C2 is going to be the sum of those two minus 180, right? Correct? We're going to have to do 180 minus the sum of 107.8 plus 48.2. Whatever that is. $24. Now this is kind of, but you see, See, it's possible. Now you have two triangles, right? Now what you have to do is you have to figure out this side C. And what you want to do is you want to do the given to figure out what side C is. You want to use C over sine of C equals, and the thing that's given to you is B. See, these are the given values, right? You could use other ratios, but to avoid rounding error, this ratio is the one that's given, right, in the problem to start with. So now what you could do is the side C is going to equal the sine of C, which is 59.6, times little b, which is 697, over the sine of b. And that's going to give you the side C. What? Sine of 59. I'm going way over on you. Do you want me to quit so you can leave?
No, you can finish talking.
Times, or you can leave if you're done. And then divide by sine of 48.2. So that's 806. And then it's going to be some point 0.4. Now what you want to do is you want to check out and see, is this C here, which it shouldn't be any different than this, by using the ratios here. It should be the same. Because this side is going to be, this B is going to be 697, and this A is going to be 890 in this triangle. And this should be the same length as that. It's flipped down and come across. Okay,